Hello, welcome to class. In this video, we'll be looking at a very interesting topic. That's change of subject of the relation, or you can call it change of the subject of the formula. Okay, now what's the meaning of change of the subject of the formula? The subject, just like in English, is the main thing. That is the main letter or alphabet or whatever that is standing on its own, that is equal to the other expression. That's the subject of that relation. So if I now ask you to change the subject of, maybe I call a particular alphabet and tell you to make it the subject of the relation, just like in this question, we are asked to make K the subject of this relation. So in other words, we want to make K to stand alone. We want this expression, this equation to be K is equal to something. Okay, so that's what this question is asking us. So there are some things we have to know. We have to take note of whenever we are doing change of subject of relation or subject of formula. The first is the way we have word and opposite in English. We have the same in maths. We have sign and opposite of it. Okay, so let me quickly put you sign and opposite. When you have plus and there's a change, plus we change to minus. If it is minus, the opposite of minus is plus. If it is times, the opposite of times is division. If it is division, the opposite of division is times. If it is raised to power of 2, that is square, the opposite of square is square root. If it is raised to the power of 3, the opposite of it will be cube root. If it is raised to the power of 4, the opposite of it will be fourth root, and so on and so forth. So, no, with this, let's look at this. Okay, so the first thing I'm going to do here is to remove this square. Sorry, to remove this square root. And what is the opposite of square root? The opposite of square root is square. So in other words, I'm going to square both sides so that this square root will go. So I will square both sides. Square both sides. So if I square both sides, I have 2t squared here. Okay. This one, tk. If I square it, this square will knock off this square root. You remember in the previous video? So the square will knock off this square root. So I'm left with t squared is equal to, so tk minus h over k minus h. Alright. So the next thing I'm going to do, let me call this, make this over 1s to balance. If you have a fraction and it equals to another fraction, the best way to make it to be linear is to cross multiply. So I'll cross multiply. If I cross multiply, we have this multiply this equals to this multiply this. So let's do it. T squared multiply k minus h equal to 1 times this. 1 times anything is the same thing as that is, so it's the same thing. So I have this. Okay, next is to open the brackets. So I'll do t squared times k. T squared times k is t squared k minus t squared times h is t squared h is equal to tk minus h. Okay, the next thing is, remember our target, we want k to stand alone. So let all the things that have k come together. So this guy here, I'm going to push it to this side and carry this one, take it to that side, so that all the k's will be on one side. So I have t squared k. This is a positive term. If it crosses, it's going to be negative. So minus tk is equal to this guy. If it moves to that side, it will become positive. Okay, so I'll have t squared h. Then this is there minus h, because it remains minus because it's still there. It did not change, it did not move anywhere. Okay, so the next thing is to simplify. Let me factor out the k. Since there is k here, there is k here, so I can factor it out. So that if I remove this k here, if I divide it out from here, I will have t squared remaining here minus. If I take k out here, I will have only t remaining here. If I do the same for h here, I will have h t squared minus, remove k, h here to be just 1. Remember our target, our main thing is just k. Okay, so the next thing is How do I make k to stand alone? K and this term, they are multiplying themselves. So anytime you have something like this, 2x, for instance, is equal to 5, and you want only x to stand alone, what you do is you divide both sides by what x is staying with. So what x is staying with is 2. So I'll divide both sides. So I'm going to have 5 all over this will go there. Remember, it's multiplication, so if it goes there, it's going to be division. So that's what we're going to do here. This is k times this term. So if this term moves there, it's going to be division. So that's what I'm going to have. K is equal to h t squared minus 1 divided by t squared minus t. Alright, and the question, that is the annual national mathematics competition, where this question came from. I think the answer is stopped here. This is the answer. If you get there, you are correct. But we can go further to simplify further. Okay? So to simplify further, we look at this. We have already made k the subject because k is now standing on its own. So this is the correct answer. But we can simplify it further. So the simplification of it, the further simplification is what I want to do now. Now watch me. There's what we call difference of two squared. It's a law. The difference of two squared states that if I have a squared minus b squared, this term squared minus another term squared, that this is equal to a plus b times a minus b. So this is what we call difference of two squared. So if I apply it here, this I have t squared minus 1. You know, 1 can still be written as 1 squared, right? 1 squared is same thing as 1. So if I apply this law here, I'm going to have t plus 1 bracket t minus 1. Okay? Fine. Then in this one is not difference of two squared, but this one I can factor out. Okay? So this one is 2 squared minus t. They have something in common, which is t. So if I factor out t out, if I remove t, if I divide out t here, 1t will remain, t minus, if I divide out t here, only 1 will remain. Are you seeing it? So I'll carry this and put back here. So I have h. For this one, we have expanded it. We have t plus 1, t minus 1, all over. For this one, we have t into t minus 1. Alright, so this can cancel out this. Since the relationships here, the relationship is multiplication, so they can cancel out. This can cancel out this. So I am left with h bracket t plus 1 all over t. So this is the final expression of k as the subject of the relation. Like I said, this answer is correct. Further, this is correct, depending on the one you have as your option. Okay, let's quickly look at another example on this. Alright, so let's look at this question. Make G the subject of the relation. So in this relation, or in this formula, in this equation, I want G to stand alone. So we start. The first thing I'm seeing here, this square root, we need to remove it. And how do we remove it? We use the opposite. The opposite is what? Opposite is you square it. So I'll square both sides. Square both sides. If I do that, square of this is t squared. Square everything here, 2 pi, square it. So I have t squared is equal to this 2 squared is 4. Pi squared is pi squared. This square will knock off this. So this square will knock off this. So I'm left with L over G. Are you getting it? Alright. So this, I can call this over 1 to balance well. So that I have t squared over 1 is equal to, this thing is the same thing as 4 pi square L over G. You can make G their common denominator since it's multiplication, okay? Alright, so if I cross multiply, I'm going to have t squared times G will be t squared G is equal to 1 times this will give me the same thing, 4 pi square L. Remember, our target is for G to stand alone. So what do? We divide both sides by what G is staying with. And what is G staying with? T squared. So if I do that, I'm going to have t squared G divided by t squared is equal to 4 pi square L. divided by t squared. So this will knock off this. I have only g, which is equal to 4 pi square L over t squared. So g is now standing alone. We're done with that. Is it not simple? Simple. So let's look at another example on that. Alright, let's look at this one. Make Q the subject of this relation. So we want Q to stand alone. So we start. Now, you're seeing something here. We're having a cube root. So I will take the opposite of the cube root. The opposite of cube root is cube. So I will cube both sides. That is, I will raise both sides to power 3 so that this will go. Okay? Cube both sides. Cube both sides. If that English is correct. But at least you understand what I'm talking about. So let's do that. P raised to power 1 over 3 raised to power 3. We are finding the cube raised to power 3 is equal to cube root of Q over R raised to power 3. Alright. So this one, this will knock off this. I have P is equal to this one, this will knock off this. I have only Q over this one is raised to power 3, R raised to power 3. So you can make this over 1, right? To balance well. So we do what? We cross multiply. If you cross multiply, you have 1 times Q is equal to Q equal to P times R3 is equal to P R raised to power 3. We are done. Q. We have made Q to stand alone. So this is the Q as the subject of this relation. Alright, so look at this question. We want to make U the subject. So keep simplifying it until U can stand alone. Let's start. You know, this is M times this, so there's multiplication. So I can arrange this as this. This is equal to, I can make this like this. Then use this one to open this bracket. So I have M times V squared minus M times U squared all over 2G. Right? So with this, I can cross multiply. If I cross multiply, I have 1 times the whole of this thing will be the same. M V squared minus M U squared. Right? Is equal to this times this. I have 2GE. Okay. So the next thing I'm going to look at here is I want U, because U is the one I'm making the subject of the formula. So I want U to be positive. And for U to be positive, let me carry U, move it to this place, then carry this one, move it to this side, so that U can be positive. Is that understood? So let me move U to this side. If I move it, I'm going to have positive MU squared is equal to, remember I've moved it here, so this one I'm bringing it to this one, so I have MV squared. Because I'm bringing this one to that side, it will be minus 2GE. Is that clear? Good. So the next thing I'm going to do is to divide both sides with what U is staying with, and what U is staying with is what? M. So I will divide both sides by M. So if I do that, I'm going to have divided by M divided by M, so that this will knock off this. So we are left with U squared is equal to MV squared minus 2GE all over M. Now what we want to make the subject is not U squared. What we want to make the subject is ordinary U. So only U. So if I want to make U the subject, how do I remove this square? What is the opposite of square? Square root. So I will take the square root of both sides. So square root both sides. Both sides. And if I do that, I'm going to have U squared square root is equal to square root of everything here. MV squared minus 2GE all over M. So the square root will knock off the square, and I have only U is equal to square root of M minus 2 all over M. So this is the answer to this. Though you may want to arrange it well, if you're arranging it well, actually the capital letter comes first. So I can arrange it. It's the same thing anyways, but just to make it look fine. So this will be minus 2 capital letter over m. So whichever direction, whichever way you arrange it is the same. So this is you as the subject of this relation. Is that understood? I believe with these examples and the understanding of the sign and the opposite, you'll be able to answer any question on subject, change of subjects of the relation. So continue to follow me for more questions and explanations. Bye.